Okay, okay. Can you guys hear me? Can anyone hear me?
Yes. I hear you.
All right, all right. Good day. It's nice to have you guys back here. My name is Nemeka, represent AI Labs, and today we have a live coding session on cache classification, is machine learning, and for now I know I'm working on popular data sets, technique, machine learning, and that's a way you are going to predict survival on the Titanic using machine learning, like if a particular passenger will survive and survive um the Titanic crash, right? So the data set is open on Cargo and you can easily just go and download it. It's still open. Like steps on how to get the data if you want to participate in a competition, and I'll recommend to everyone to just test it out, try it out and see. Okay, so I have a notebook prepared for us already. Let's get down. So I got this notebook from also Cargo and I made some touches. Feel very, very helpful. It's self-explanatory and yeah, with a lot of markdown for you to like follow um, and see by yourself, right? So we're going to start by importing the data sets and yeah, I've imported the data set, data sets. Yes, I imported um, pandas library, Seaborn for visualization and some machine learning libraries from SKLM, right, that we'll use further down the road, right? So as always, you always want to like look at your feature set and what are you working with? What's your target variable? What's your feature? And what are they all about, right? So simple data analysis, right? And so if I print out like the column names, right? You can see like they are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 columns, right? And not all of them will be useful, right, for the machine learning task. As we go, we see the ones that are not useful and the ones that are useful, right? And so to explain most of the feature names and what they are about, you can always go to the um, cargo page, right, and see what it's all about. So what we're predicting is survival, right? And it's just two categories. That's why it's classification, right? In regression, we predict a continuous variable from one to whatever. But in categorical, you're most likely classes you're going to predict. This is just a binary class classification. There's things like multi-class classification, so on, right? So the P class, the ticket class, there are different classes, in a ship, Titanic. There will definitely be classes like in an airplane, right? So there are three classes. There was the sex, like gender, age, S, SIB, SP, SIB, meaning the number of siblings and spouses aboard the Titanic for the passenger, number of parents or children aboard the Titanic for the passenger, the ticket number, the passenger fare, like the cost of the ticket, right? The cabin number, that means the cabin at the stage, and the port of embarkation. So that's where the ports that they ship from, right? And they also explain what all this means, right? For us. So yeah, we don't really need to do a lot of research on what all this means. So okay, so let's go on. And so we determine which ones are categorical and which ones are numerical, right? So from here, we can see that the survived is categorical, the class is okay, there's ordinal. And I don't know if I know I said this in the last session. Ordinal means that there's a kind of ranking. So the first class is most likely higher than second class. It's higher than the third class. So that's why it's ordinal, right? The categories have meaning, sense, right? That one is higher than the other, one is better than the other, right? So that's why we call it an ordinal class. I hope I'm audible enough. Please. All right. So we have the sex also, and male or female, and we have the port of embarkation, whatever it's called. So they shortened it to SC and Q, right? So as we go on, we'll see like what all this means, right, overall, and we'll do some kind of exploratory data analysis and see how these different features affect the survival of the passenger. Okay, so if you look at also like the head and tail, like these methods, right, you can see that the the cabin, for example, has a mixture of numbers and alphabets, right? So and it makes sense because they're like the room numbers, right? Or cabin numbers in the ship. So yeah, that's why it's like that. And the ticket also have it's also alphanumerical with different ticket numbers to identify different passengers. Right. So and also we can also like check out like the missing values and we can also check out the missing values and the, the missing values and how their feature types are, like the data types are, right? Sorry for that. Um, so the missing values here are age, right? The cabin, you can see that instead of 891, the cabin has 204. So maybe it was not recorded or something like that. Embark, that means where they embarked from 889, right? Age also, some people did not impute the age or it was not found what their age was, right? 714. And in all this, we have to find out a way to like impute the missing value because, like I said, you can't use that to any modeling because you most likely throw an error. Or some of the models actually, but for some models, they actually work with missing values. Models like XGBoost, like GPM, AdaBoost, they all work with missing values, so they won't throw errors. But for models most likely from SKLearn, they are always like throwing errors, maybe missing values. All right, so next thing first is just like a description of the numerical feature, right? The statistical analysis of what it's what it is, right? What's their distribution, the mean value, the standard deviation. Some of it doesn't really make sense. Something like passenger ID. The passenger ID is just the number, the count of the number of values, right? So yeah, 891, the mean of one. This isn't important for us. Also, the survived side, you can see that 38% of people survived, right? But actually, in the statistics from the Titanic itself, 32% survived because if you scroll up, or sorry, if you go into the um, Titanic page, you see that they had 220 passengers down, 1,502 died. And that was the 32% survival rate. But this is a data set of only 839, 890, 891, right? So that means that it's just a say let's say a subsample or subclass or a subsample of what it actually was, right? But the statistic is almost close. 38 is close to 32, so we can always work with that, right? Um, You can also see that the most passengers didn't travel with parents or children, right? Um, okay, what's this? And we see that also from the age, the maximum was 80 years, and the 75% percentile is 38. So most of the passengers were far below 80 years, right? You can see that 75% were below 38 years, right? So um 80 is just like an outlier, right? It must be a very elderly passenger at that time. And also the prices of the fares, you can see that some paid between some of $512, and also it's queued too, right? Someone paid as high as £512, and you can see that their value is like the 70% that was $31, right? So there's also like some significant differences in fares that were paid by the by the passenger. So we'll explore more why this is on how it affects the actual survival rate of a particular passenger, right? So we can also do like a distribution of particular variables, and we can see like the frequency of like the frequency of sex or gender that were in the passenger list, right? There were more males. Somebody asked me a question. If you are not, please mute your mic so there are no distractions. All right. Thank you. So no, I don't know if this will make sense, but okay, the ticket and cabin are not really important but variables for me because they don't imply whether if you have a ticket doesn't mean you survived or not, right? It's just I don't find it as important, right? Also the impact, you see that the most likely impacted from Southampton. Most passengers embark from Southampton, right? Southampton ports, and the frequency of 644 of them. There are three unique, like we all know. And so let's like go down and do some like real respiratory data analysis of like and see how this affects, right? So we can always do analysis with pivot tables, right? So pivot tables are like between statistics for like just doing simple statistical inferences, right? So in pandas, you can always use a group by, right? Group by P class and do a mean, right? And you sort by the survived values. I don't know if you have played around with pandas. This particular syntax should make sense to us if we have played with pandas and so what this does is just that it selects the P class and survive from the whole train here, right? It selects those two features and it goes by P class, right? So when it goes by P class, it's kind of just puts all of them into buckets, right? Which of them are in P class one, which one is in P class two, which one is in P class three. It puts all of them in buckets. Then with that, you have to do it like a summary statistics, right? You can do a count, you can do a mean, you can do a median for all those values in a particular class, right? So you can always do a mean. You then sort it by survival rates, right? And we can see from here that if you are in the class one, right, you see that they had the highest survival rates, and those in the last or the least class where they didn't survive that much, right? You can see from this and this. Okay, also, if you do the pivot table for the sex and the survival rate, we can also see that the the females had a higher survival rate than males, right? And if you also try it with some other features like the siblings and spouse, there's there seems to be a correlation, but it's not really making sense, right? You see that it's 0, 5, 0, 4, and it's not really making sense. But for now, we can draw inference from like the P class and the sex that these variables have like a correlation. I'll put like a correlation with the survival rates. Right. So if we go on again to visualize with with actual images, right? We see more, draw more conclusions, or we can draw more conclusions from visualizing with images, right? So if we go on and do like an histogram of the survivors, right? You will see that these are people that survived and these are people that didn't survive. That's zero. This is one. You can see like from this x-axis is the counts, right? The count of proportion. You can let's say it counts, right? And you can see overall that more people didn't survive. But if you look around this side, I don't know if you guys can follow my mouse. That's that's these people, this in this age group of 0 to 4, right? They survived, right? They survived more. The elderly also survived. And from where we see that people from ages 20 to, I don't know if this is 45 or so, or 15 to 45, did not survive, right? So you see that the age is a very, very like important like factor. It's a very, very important factor. We have confirmed that it's a very, very important being, right? We can be ages to help the model out to it helps the model out when we like being in two categories. Like from these visualizations, we can now do like a binning from 0 to 15 or 0 to 14. Then we do a bin from 15 to maybe 35. And bin it it kind of like helps the model to know that the people in this bin most likely didn't survive, right? So um let's go on, let's move on. I'm trying to do as fast as possible. Okay, the oldest passenger survived, yes. Infants had a very high survival rate, and most passengers were between 15 to 35. Actually, if you combine these two histograms together, remember that 15 to 35 is the age group that had more people, like more passengers. So also, if you draw the histograms of each of the classes and their survival rate, right? We can draw some inferences from this. Like if you see the P class, the highest class, right, and you see that from here, from like in this side, the P class 1 had the highest count of people that survived. Right? You can see that the class 1 had the highest survival rate, but also the class 3 had the highest number of people that didn't survive. Um, this is sad, but it's from data sets that we can see that, right? So see that the pictures had most of passengers, however, most did not survive, right? Pictures had the most. Okay, we cannot say that. We can say that maybe it's because there were many of them in the P class, right? There were many passengers in the P class, and because of that, most of them didn't survive. You can see that, and also you can see that the P class had a very low number of passengers, and most of them survived, right? So the infant passengers in P class 2, yes, they survived. You can see that from this side that they were like they survived most in the P class 2. The infants they survived. So you can consider the P class for model training. So you can see that there's like how let it there's a correlation, there's help, is going to help us. There's prediction power in the future. So we can continue with that in the machine learning model. So if we continue also, this is a point plot, right? A point plot just helps us with categorical plotting categorical features with numerical features, right? It helps you like see like any patterns in categorical features and a a target continuous or targets numerical feature, something like that. And so if we see this is different places they embarked from. There's Southampton, C and Q, right? And we can also see that also their classes are there, right? And from all of this, we see mostly like that the females had high survival rate, except from those that embarked from this particular pot. We don't know why that happened, but we can see that here the males survived more than the females, at least from from the passengers that embarked from the port C, West Port C, Cherbourg. I don't know how to pronounce that, but we can see that also that the female passengers had much like survival rate than males, right? In in this particular port, there's an exception, right? You can always find out why there's an exception, but I don't know how you go about finding out that. In some cases, you want to find out the reason why this is happening, for you to also like create features from there and like help you out to model, right? So males had better survival rate in P class 3 when compared to P class 2 for C and Q ports. And so yeah, we can also draw to the conclusion that okay, from here that the male and the sex and the embarked features also have like a a a pattern with them that we can use to help in our modeling, but help us to build our model, help us to help the modeling, so deciding it. So we decide that these particular features, embarked and sex, will most likely be helpful, but we also need to complete them, right? Because if you remember, the sex and the embarked feature had missing values in them, right? They didn't have, so we have to find a way to impute them. And there are so many ways to impute categorical features. You can always use the highest number of the mode, right? What mode means that is the one that had the highest frequency. You can do that. Or we can always do smart ways of maybe a group by. Then when you do a group by, you can use the mean or the median to impute the missing values. We'll see that in the future, right? So you can always plot more to how able to also like help out. This is the fair feature, right? You can see that the people the C the people that embarked from port C pay the most, right? Pay the most compared to the rest. So there must be a reason. There must be like some kind of reason why that port had the highest fares. And you can also see that the people that paid the most survived the most, right? You can see that the ones that paid up to fare 80, or the mean payment of 80, right? Or the median, that's the median. But okay, so we can see that these people pay the most and they survive, right? And the people that didn't pay that much, survive less, right? So we can also see that there's a relationship between the, the port where they embarked from and the price they paid. So maybe it's the port is this better, or it's I don't know how that works, but it makes sense from data from our visualization that the fare also matters in a survival rate, right? So since we luckily for us, there are not many features in this particular data set. There were just like 8 of them that mattered, right? 8 of them. And we have like seen the top 5 that will matter for us in our modeling phase. So we can just do some wrangling, right? We drop some of those features that we didn't need. Like I said, the tickets and cabin shouldn't matter, is not going to matter in the like for the future of predicting who will survive and who will not survive. So you can always drop them, right? And now we can now do something called feature engineering, right? Feature engineering is like a very, very important aspect of like machine learning, where you like create features you think that will help the model in in predicting better, increase the accuracy, right? So that's, don't know if there are any questions. Sorry. Don't know. All right. All right. So the first feature we're going to create here is the title. title as in we're going to use regular expressions. I don't know if you know about regular expressions, but regular expressions are just like yeah, like like you have a pattern in a string, right? And you want to extract some particular quote or particular sentence or particular words, right? Like in your emails now, like when you type in your email in something like Google Gmail or any place where you register, how can they know that this particular email, this particular string you type is an email, right? And to throw you an error that this is not an email. Something like when you type um to maybe or to maybe 321.com, how does it know that it is not an email, right? We use regular expressions. We use regular expressions to check the format of it. And sometimes they go this is a very short one, but the one particularly for the email is very, very long, right? So let me continue. I just wanted to explore regular expressions. So what this regular expression is doing is that it's going to if you remember, let me do it from sorry. If you remember in the name, that's- in some of those names, you find out they were like something like titles in them, like Mr. or Master and Doctor. It's not me. Sorry, yes, it's been removed. I've already removed it. I ran the script from what is supposed to be here. Okay, so we can see that there's Mr., there's Miss, there's Reverend, there's Doctor, likes like that, Mrs., right? So what the regular expression is going to do is going to find the pattern that has this after a comma. It's going to pick out the title before the name, right? And we're going to use that title to help the model because you see most likely that a miss or a master will have different survival rates, right? A captain have a different survival rate. So these are this will be very, very helpful in the machine learning model to predict better, right? So that's where we right. So what it's going to do is going to extract those titles, Countess, John, Doctor, John Care, Lady, and it's going to create a new feature set. Sorry, it's going to create a new feature set with them. Then what we're going to do is that we're going to replace some of them, like Lady, Countess, Captain, Colonel, with rare, right? Because there are going to be a whole lot of different categories of them, and we can just replace them with rare, right? Then there's the miss, there's misses, right? These are just different ways of them writing it. MLLE, MS, and MLE. They're just different ways of them representing it. And when we do that, we're not going to like find out a pattern. Like we're going to do a group by like we always do, and we're going to calculate a for each of them. We can see that the miss and the misses had higher survival rates than Mr. And also masters, because masters are very like young. You see some of them are young boys. And you can see that they also had a very high survival, a kind of high survival compared to the Mr. So we can see that this particular title feature very, 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 very important in our machine learning process, right? We also want to convert those categorical titles to number, right? You can to a mapping from Mr. to 1, Mr. to 2, Mrs. to 3, Master to 4, Red to 5, right? So what it is just like giving categories to each of those different titles, right? So there's a kind of ordinality which is like order, like Mr. before Miss, before Mrs., before Master, before those variants like Doctor and Colonel, right? So we created that feature and we dropped the name because most likely the names are important. The name doesn't matter. It's not going to be important in machine because like always, name doesn't matter. And the passenger ID are just like the number that they are assigned to them. So we want to drop that too. And also remember that machine learning models deal with numbers, right? So always we have to convert um, each of those categories to recuperate value to female to 1 to 0. Then we can do that using the map function in Pandas library, right? When we do that, we see that the the males have turned to 0 and females have turned to 1. And this is like another visualization to confirm, right? We want to um, impute the ages, right? There are some missing values for the age and yes, for the age, and we're going to use something like P class and gender. Like I was saying, like there are missing values for ages, right? And you want to like impute them. You can always use a random value, like just using the name age, right? And just imputing it, or you can just use the standard deviation or the median. Right? But there's also a smart way of like doing a group by and imputing those using those group by the median, right? And imputing the missing values around them. So that's the step that I was taking here. We can always look at the notebook and refer back. Also, like I said, we're going to do something called binning, right? The ages are like continuous values with outliers, right? If you remember in the expression class, we did something like a Lockwoodian transform on the age or some of those features, right? Because of the way they were skewed, right? Another way of of solving that problem is like using binning, right? By binning the features, right, into like categories, 5, 6, depending on what you have gotten from your analysis. Sorry about that. So whatever you get from analysis, you now use that to do your binning. And we did use 5 categories here and we binned them, right? And from binning, you see that it's very, very important. Like you see that those from 0 to 16 had survival rate compared to those ages from 64 to 80, right? So we can now like use like some method like this to like bin them to 0, 1, 2, 3, I think 4, right? And that's what was done here. So we now remove the age, and we now create new features too from the sibling spouse and the parents child, right? We just join them together to know their family size, right? And this is what was done here. Added them and we just looked at their survival rates. And we also did the if alone, right? Is the person traveling alone? And we found out that if the person traveling alone, to see their survival rates too, is it going to be helpful? And most of the times, those features that you create are not most likely helpful. Like the family size now, there's no like pattern, right? There's no like pattern. So you can say, okay, the family size of 4 survived more, but you can't really draw any trends from that because you not see 3, you not see 8, you not see 11. It's not like pattern. So most of the time, those features that we use are not really helpful. So you end up just dropping them as a whole, right? But we left the EC alone because there was like a clear pattern in it for us. So you can always create features to like from a combination of classes, right? You do a feature cross, right? You multiply 2 classes together or add and find out that there are patterns between them too. and we did that to form the H class feature, right? Um, we also remember that the embarked column, the embarked feature had the missing value, right? So we drop, we drop the NAs. We now use the mode, like the highest frequency to just impute into those particular features. So we just use the S and imputed back into those missing values. That was just a simple way. We converted back to numerical values. From there, we are seeing that we have we have mostly numerical values from here, right? So the last thing we can do is now to do a binning also um, for the price, like the prices for the tickets, right? And when we do that, because we found out that they were also it's also skewed, so like there were people that paid very high values for prices, and the people that paid very low values, and this will affect your model too, right? So to solve that, you can do binning for the fair price too, right? And when you do that, we have like 10 different bins, like from 0, 1, 2, depending on the prices that they paid, right? And so this is all the feature engineering that we have gone through for this particular task, right? So you can always do more. You can always find more like feature crosses, feature interactions, which one is affecting the other, and other feature interactions too, and feature engineering steps if you want to. So I feel like this was a lot of material for today. I don't know if there are any questions from now. Most likely end it today and continue with the modeling, um, classification, and the confusion matrix, and the F1 score, and the lives from next week. So, yeah. See next week on Friday. Yeah, we'll have a next session on Friday to explain more. So, are there any questions that you have for me? Any questions, please? You can type on the chat, or you can raise your hand. Questions, no? So, the notebook. Okay, yes, we'll get the notebook as usual. Yeah, we will. You will. By the end of today, I will send it to Amoy to send to your group chat. Um, I know this must be a lot of, I don't know if it's a lot of content, right? That was put into this. I was just sharing us like some things we will most likely see in data science field, because your data sets, you might always do some feature engineering. There might be other features that you need to create to help your machine learning model to be better or get better, right? So that's why most like if you explore this notebook and some other materials, you surely understand everything that I did today. So so by on Friday we'll do the machine learning part of it. I hope everyone is okay. I don't get the question. Is it from the cargo? Is it from the cargo class? Is it from the cargo? Okay. Please. The question. I will relay a question to Amoye. Um, feeding me, so we can resolve that. Okay, so that will be the end for today. Okay, that will be end for today. Happy coding. Please try your hands on most of this code, experiment, and you surely get better. Read materials, read blogs, and you surely understand most of the materials. Most of the things I said today. All right, take care.